Okay, guys, for the last couple of days of class, I am just going to kind of highlight a couple lessons I think are things that, just picking out a few lessons that I think are important and would be good to know for next year walking into Math 30, whether you're taking -1 or -2. So just picking out a few, I might do a systems of equations lesson, I might do a transformations lesson. I will not be assessing you on them, just for your own knowledge, okay? Maybe I'll assign a little formative quiz by the end of next week. So if you remember from Math 10C, we did a whole chapter called Systems of Equations. And Systems of Equations is basically when you have two equations and we solve using substitution or elimination. And what we're always looking for the solution is the point or points of intersection. So in grade 10, we would have just looked at like something on a graph like this. We would have only looked at linear things. So if I have an equation like this, an equation like this, I have a point of one point where the two graphs can interact with each other or they intersect at that location, and that is my solution to the system of equations. So in Math 10C, we did a linear system that would look something like this. In Math 20, we're doing quadratic systems because now we understand what a quadratic equation is, what a graph looks like for it, and the solution or solutions are just going to still be those points of intersection. So how do we find them? So I just want to show you, this lesson is great because it quickly shows in just one example how to do it algebraically and how to check it by graphing. Okay. So anytime we are looking for a solution to a system, we're trying to find those points of intersection. Now, typically in Math 10C, a lot of people liked using elimination to solve their system. But elimination doesn't really work for us in Math 20 because it's hard. I have kind of like three different variables here. I have an x and an x squared. There's nothing I can just times everything by to get rid of two variables at once. So we're usually going to set this up using substitution. And we're going to set it up via substitution to say, well, if y equals all of this, let's replace this y with that equation. So my very first step is to essentially set the equations equal to each other, but the key idea is that I am doing substitution. I'm replacing this y with this equation. So I have 6x squared plus 7x minus 4 equals 2x squared minus x plus 1. And now we know how to solve something like this. We can bring everything to one side. We can determine if we have to factor, if we have to use the quadratic equation. And then below, we're going to check this through graphing. So let's take everything to one side. I'm going to subtract the 2x squared, add an x, and subtract a 1 from both sides. So this will all go away. I have 0 over here. On the other side, I'm going to have 4x squared plus 8x minus 5. And looking to factor this, hoping it will factor. So coming up with numbers that add to -8, positive 8, sorry, and multiply to -20. Looks like a 10 and a 2 would work. So a positive 10 and a -2. So 4x squared minus 2x plus 10x minus 5. Factor up a storm here. I'm going to take out 2x, left with 2x minus 1. And I'm going to take out a 5, 2x minus 1. So my factors are 2x plus 5 and 2x minus 1. Which means my solutions take each factor, set them equal to 0. The first solution I'm getting is -5 over 2, and the second solution I'm getting is +1 over 2. Now, whenever I I have two different values for x, so that means that there's two locations where these graphs will cross each other. And that makes sense. Parabolas, whenever I draw them, they could intersect in more than one location. So I have two x locations, which means I just need to, in order when I state my system or my solution, I need to state it as a coordinate value. So I'm just going to go back to like each equation here and plug in that value of x and find the corresponding value of y. So let's do the positive half first. So I have 6 times a half squared plus 7 times a half minus 4. So just plugging in that value of x, I'm going to come up with the value of y. I'm going to do it right in my calculator. I'm getting 1 for that one. So y equals 1. So I'm just going to write my solutions over here where I have room as two coordinates. So the first solution, when x is 1, y is a half. The second one, when x is -5/2. I'm just going to copy and paste that and replace the decimal inside there. So -2.5. And it doesn't matter what equation from the start that you chose to put your x value into, you'll get the right y value regardless for each one, for either one, sorry. -4. I'm getting 16. So when x is -5/2, y is +16. So algebraically, we have our solutions. Now B is saying, now let's sketch it and see if we are right. So let's sketch the system of equations on the grid and determine the solution, and we're supposed to state an appropriate window. So in order to do this, I think what I will do is open my graphing calculator. So I'm just going to move my screen around here. And wait for it to open because I didn't already have it open. Whoops. To solve the system graphically, I am going to, in my y equals line, just make sure, oh, I am writing still. That's why it's not working. Oops. Okay. I am ready to go here now. Okay. In y1, we'll type the first equation, which was 6 x squared plus 7x minus 4. In the second equation, 2x squared minus x plus 1. Okay, I'm going to graph those guys now. And I can definitely see one of my systems of equations intersections here. If I draw here, I think it'll work. Yeah. So I can see that there's like one system or one intersection point right there. And it looks like it's about x positive a half, y positive 1. Like that is looking like the right answer. I can't see the second one right now though. So that means I'm going to have to change my window. And it looks like it would be up higher. Like if I'm looking at the graph in that top corner, it looks like they're getting closer to each other, but I can't quite see it. So let's change my y max to like 50, just to see lots of space. Okay, now I can see 2 points of intersection. I'm just going to circle them. Something around there and something around there. Now to find those on my graphing calculator, I'm going to press zoom. Sorry, second function trace, not zoom. And I'm looking for those points of intersection. So I'm going to press number 5 for intersect. And it says first curve. And we're just going to choose the intersection points one at a time because there is 2. So I'm scrolling over to wherever the first point of intersection is. I'm going to press enter on it basically 3 times. First curve, second curve, and then guess. And then it's giving me that point of intersection. So that was one of our points, -5/2, -2.5, same thing. And +16 was a solution to this. And let's go find that second one. So second function trace again, 5 for intersect. And this time I'll scroll way over to wherever that second point of intersection looks like. And I will press enter, enter, as long as my cursor stays around that one. And that one's at 0.5, 1/2, and 1, which is exactly what we were looking for. So we just kind of verified it graphically here. And then in the last step, C, we're being asked to verify that the solution obtained satisfies both equations. I'm just going to make this big again. Okay, I guess I should draw a little sketch here. They look something like this. This is not going to be perfect by any means. I actually don't remember where this one intersected. No, it was positive. Oh no, I can't draw it. Okay, I don't think I'll draw it. I just showed it on the screen and I can't go back now. That's okay. Let's just go to the verify. Verify that the solutions obtained satisfies both equations. So to check that it satisfies an equation, the first equation was y equals 6x squared plus 7x minus 4. And we're just going to choose a solution. So let's choose the positive 1/2 and 1 and check it. So if I use these coordinates as x and y, does left side equal right side? So if y is 1, 6 times 1/2 squared plus 7 times 1/2 minus 4. And you can do this all right in your calculator if you want. It does equal 1, so you're just looking to make sure that 1 equals 1. Verify the second point, and really you just have to do 4 verifications. So you're going to check it in this equation, check the second point, negative 5 over 2 and 16. 16 equals 6 times negative 5 over 2 squared plus 7 times negative 5 over 2 minus 4. And we should be getting 16 equals 16 when you type that in. And then you can do it again a second time just to be sure. If left side equals right side, we have a good solution. Okay, so I just wanted to get you to practice some of the graphing calculator skill here and substitution skill. I'm just going to assign questions number, if I just go to the next page, I can show you. Question 1 is very similar to the first example there. So try that one. Question 3, there's 4, or A, B, and C here. Just choose one of them. Try it out. And same thing for 4. So I'm going to just assign questions 1 through 5. For number 3 and 4, just try 1. Okay. And just make sure you can solve that system in your calculator. That's something we will use often, is to check solutions. Is to say if I just take 2 equations and find their intersection, I'm always getting the solution to what I'm looking for. So that's a good skill to take into 30-1 or 30-2. Okay, give those practice and let me know if you need any help.